Hi guys, welcome to this brief introduction to the celestial sphere. If you go out at night and you look at the night sky, hopefully it's clear enough for you to see objects in the night sky, mainly the stars. You will see thousands of stars depending on the conditions of light of where you are, namely light pollution, okay? Objects in the sky appear to be moving in some sort of a scene that is part of a dome, basically, structure. And that dome structure changes from hour to hour if you watch it, okay? That is due to the rotation of the Earth. It is a useful concept to try to locate objects on this dome. Granted that if you move actually on the Earth, what you will notice is that the patterns in the stars, actually the bright stars, change location, and even others that you did not see before you start seeing. As a matter of fact, if you go through the entire Earth, you will see the entire night sky, namely the entire celestial sphere. Now, objects appear to be located at an equal distance from the Earth, and that is not true, because we don't have really perception of the depth. Some objects are closer than others, but because of their brightness, some objects appear more so brighter than others. That depends on their temperature and their distance also. As a matter of fact, with the exception of the moon and probably the planets of the solar system, everything else within light years away from us. Some of them are few light years, others are hundreds or even thousands of light years from us. Nonetheless, we can locate these objects in the night sky using similar techniques on how we locate objects on Earth. On Earth, it has three characteristics. So this is basically an illustration of the Earth. It has a North Pole. On the opposite of that, there is the South Pole. So you have these 2 points, which are considered the North and the South Pole. If I travel from the North Pole to the South Pole, right midway, I'm going to encounter the equator of the Earth. For me to locate objects on the Earth, what I do in this case, I ask, how far are they from the equator to the north or from the equator to the south? That is one point. Because of their spherical shape, more or less the Earth, I can actually use angles for that. I consider this one 90 degrees. And then if I move down, I'm down to 0 degrees. And if I go back, I'm going to go to the negative 90 degrees, basically. Anywhere from positive 90 to negative 90 gives me any object from north to south of how it is located. Now, if I am on the same angle distance from basically the equator, I can describe a full circle, actually. So any object on that circle has the same location with respect to the equator. We call this location the latitude of that object. Some cities are on the same latitude, meaning that they have the same, they can see the same night sky. Because as the Earth spins, whatever these people were looking at, the other people have seen already, or vice versa, as long as you are on the same latitude. So in order to define an object specifically on the Earth, then you need its location with respect to some sort of an imaginary line. By convention, everybody agreed on the line that passes through Greenwich, namely a prime meridian being the origin of that direction. Now, every object then can be located to the east of that line or the west of that line with specific angles. So now we have a way of finding objects on the Earth. Similarly, if we project this North Pole from the Earth to the dome above us, to the celestial sphere, we will have the north of the celestial sphere. To project the South Pole from the Earth to the celestial sphere, we will have the south of the celestial sphere. If we take the equator of the Earth and project it to the celestial sphere, we will have the equator of the celestial sphere. Now, we have means also of locating objects on the celestial sphere using similar measurements, with the exception that instead of a latitude, which is from the equator of the Earth to the North Pole of the Earth, we will use the declination, which takes us from the equator of the celestial sphere up to the north of the celestial sphere, or from the equator down to the south of the celestial sphere. That is one way, but that still leaves us with a big circle that we need to find, and that one we use the right ascension from a line similar to the convention for the prime meridian. Then we will have measurements with respect to that on where the objects are. Now we can find exactly where they are. The only difference is, instead of using degrees for the right ascension, we'll use hours. In other words, dividing 360, dividing a full circle by 360 degrees gives you degrees, or dividing full circle by 24 hours give you 24 hours. So this is basically the divisions that you're going to have. Now, this is how we locate objects in this celestial sphere. So let me share with you the Stellarium software that we've been using to show you how this looks like if you happen to go outside and look at these objects. Okay. Again, I turned the declination and the right ascension on. I can turn them off. And I actually also turn the ecliptic line on too. The ecliptic line, if you guys remember, is the path that the sun goes through the entire day, basically 24 hours, okay? And that is more or less where all the planets also happen to move. So this is the ecliptic line, which is an important aspect of it. So let me turn this measurements again. So the center, or the north of the polar of the celestial sphere, is where Polaris is located. So if I zoom in, that is where the star Polaris is located. It's slightly off, okay? So that is actually, when I zoom in, the star is slightly off of the north of the celestial sphere. As on the opposite direction, there is actually the south of the celestial sphere, okay? Now, there's circles in here that are represented around the center. They are actually the declination lines, okay? Similar to the latitude lines on Earth, and they are circular in shape. The lines that emanate from the North Pole and end in the South Pole and come back to the North Pole from the other side. So if you follow this line, at some point it's going to meet the South Pole and it's going to come back from the other side. That is actually the right ascension lines. Okay, so any object in the night sky can be located using these coordinates. Okay. The type of objects that they see in the night sky, of course, the stars, the planets, and also the moon. In addition to planets, they form specific patterns. So the night sky, the celestial sphere, is divided into 88 of those patterns called constellations. Okay. Now, constellations, they appear in 3 different types. There are the so-called circumpolar constellations, like Cassiopeia, for example, or Ursa Minor. Those are important constellations. You don't have to know all of the 88 constellations, but at least some of them are useful, trying for you to navigate your way through the night sky. Okay, one of them is Ursa Minor, and let me turn off this thing in here so that you can see its shape. So at the end of it is where Polaris is located, which is an important star. It helps you also navigate your way at night. Okay, Cassiopeia is another example of the constellations that move around throughout the night around Polaris. Those are called circumpolar constellations because they move around the polar star. Okay. This is for us on the northern hemisphere. If somebody else on the southern hemisphere, they will see different constellations. As a matter of fact, they will not see Polaris. They will see different stars in there to help them guide themselves throughout the southern hemisphere. Okay, again, remember the half dome. I'm in the half sphere, which is dome on one side and dome from the other side. And there are other types of constellations that seem to move around the ecliptic. Okay. And those are the signs of the zodiac, namely the zodiacal constellations. Case in point, Gemini, Cancer, Leo, Virgo, and all of these constellations that are part of the sign of the zodiac. Okay. In addition to that, there are also other constellations that fall below the horizon and come in different seasons, called seasonal constellations. So these are some of the objects we see. This is an introduction to the celestial sphere, and we will have activities related to it. Thank you.